Okay, Shonat, can you see me? Hello?
Hello.
Yes. So we'll learn today the friction and braking in the physics, okay? So first we'll need to understand what is friction. Do you know the meaning of friction? What is friction?
Friction is gravity that's basically gives the opposite reaction of a force.
Yes, one kind of impact is there on gravity, by the gravity, but there are many more definition is there in friction. This has confused our understanding of how it is involved in friction, blister formation. So if we define easily, the friction is the act of rubbing one thing against another. Okay. The force that resists relative motion between two bodies is constant. That means if something is rubbing with one another, the another force is there. It is working opposite direction. Okay, as you have seen in earlier also. Let's see today. So this is one object and this is the plan, or you can say this is the path. Okay. So when I'm putting the force, when I'm applying the force, it's trying to move, right? See, one red force is there. See, this force is working as a friction that is opposite to the direction. We are moving this object this rightwards, but the another force is working automatically opposite to that. That means leftwards, red color. Can you see that? So that is nothing but friction.
Friction.
Force. Okay. If friction is lesser, we can move faster. Force will be faster. See, this is wood we have provided here. If we put ice, you will see that friction is massless. Even no friction, you can say. There is no opposite direction. It's a plain and smooth surface. Okay. So this working as a gravity is working downwards. Okay, and the force from this pathway is working upward. Okay, so if we put the wood, then gravity is there, but we are providing the force in one way. The another way, the automatic one force is working, that is a friction. So friction is the act of rubbing one things against another. The force that resists relative motion between two bodies is contact. It is resisting, right? The backward force, it's resisting. So the object is stopping. That's a friction. So to understand how friction causes blister, the second definition is needed, and we are going to get even a bit more specific than that. The involvement of friction is what? In friction, blister is easier to understand when you talk about static and dynamic friction. So friction, two kinds of frictions are there. That is, one is static friction, another one is dynamic friction. So what is static friction? Static means what? It's a constant, right? So static friction is friction that occurs between two bodies in contact with one another while they are at rest. That means this object is at rest, right? It's not moving. It's contacting with one another, but still there is one force acting. Okay, that is called,
that is gravity.
Yeah, gravity. And that is called static friction. Two bodies in contact with one another while they are at rest, means in a stationary position. It's friction which prevents an object from moving while it is still. The friction is protecting it from moving. It's helping to stay there, becoming the stationary. Okay. So this is called static friction. Another one is dynamic, or in physics, it's called kinetic friction. Okay. So you know the meaning of dynamic. That means it's increasing, decreasing, or it's related to kinetic, kinetism. That means force, right? Friction is friction. That means dynamic friction is friction that opposes the movement of a body which is already in motion. Its friction that slows or stop an object from moving. See, when you are moving this one friction is activating. See, red color F, force is there. Okay. So when we are putting force more than the friction, it's moving, but still it's remaining until it's stopped. Suddenly it's when we release the push, what is happening? The friction is working. First it's slowing down, then finally it's stopping the object. This is called dynamic friction. Got this point?
Yes.
So how does friction cause blister? What is blister? What do you mean by blister?
Blister is like that what happens when you burn your finger. It's the aftermath of a finger burn.
Okay, okay. That means blister will make a what? You will feel some
a lump of liquid.
Yeah, it will make some burning, right? The static friction
Yes.
blister because it results in more shear than dynamic friction. Imagine a foot as a wobbly box helps to explain. So let's see this one. See, this is wobbly box. The effect of friction is what? Look at the wobbly box. What you can see?
It's a
the movement force at the top. We are pushing here on the top. Okay.
Yes.
Is from the bones as they move back and forth. This you can move back and forth. And the force of friction is what keeps the bottom of the box stationary at the bottom. So it's the flexible. So if you put the force here, if you use the force here, let's say something force. So what will happen? It will go front, but the top will remain in the same position, in stationary position. Okay. The force of the friction is what keeps the bottom of the box stationary at the bottom. It's still there, but it's not moving. But since we are putting the force here, it's a flexible, so the upward going front, forward. So it's a state of static friction because this one is static friction. Due to static, it's remaining same. This is moving friction or dynamic friction. Everything in between the top and bottom is made to stretch and distort. So everything, it was something like this straight, but when we are putting the force, it's making the distortion, right? Stretching. This is called shear. S-H-E-A-R. The name of this stretching is called shear. Blister are an injury of repetitive shear distortion. That means if we keep on pushing the force, okay, have you worked with clay? That means what is that?
That toy called Play-Doh.
Yes. So when you are working with that, what is happening? You can move it like this by pressing and moving. You can create the shape, right? So
yes.
This is because of friction. The blister is happening and it's changing its shape. So to stop blisters, we can either do something at the top of the woody box, that is reduce bone movement, or we can do something at the bottom of the woody box. Wobbly box. This is actually wobbly box. Reduce friction to make it more slippery. If we put it in the slippery floor, this distortion will not take place because the force somehow it will keep on going forward, right?
Yes.
So what causes the blister? Static friction causes the blister. A state of static friction is exactly what we see with the wobbly box. There is a movement force at the top, but no movement at the bottom. Lots of shear occurs in the middle. So many shears is happening. It's distorting in different places. Now, if that wobbly box was to move at the bottom, if we put the force here, what will happen? That's what you would call a dynamic motion. Makes sense. Static means still, dynamic means motion. Okay. So if we move in the downward, bottomward, what will happen? It will keep on moving. This object will be moving. Rather it's making it bend or flexibility. Okay. Here is some things you probably already know about realizing. Have you ever tried to push a heavy box along the floor and found that a big effort is required to get it moving? Have you tried that one?
Yes.
But once you get it going, it's easier to keep it moving. That's because the force you need for the box break free of static friction is higher than that the required keep to in a state of dynamic that we have seen earlier. So this is box.
Oh.
This is box. When we are trying to move, see, when we keep on pushing, so it is easier now. Now it has broken. Okay, we can see friction is still same, right? Friction, the more force you give, but friction is still same. So it's keep moving. Okay.
Yes.
That's because the force you need for the box to break free of static force is higher. See, force is higher than the static force, right? See here, the length. You see the length of the force is higher than the length of the C is higher than the friction force. That is called keep it in a state of dynamic friction. So unless your force is greater than the friction force, it will not move. As soon your force is greater than the friction force, it's keep moving. Okay, this is dynamic friction. Have you got this point?
Yes.
Is it clear?
Yes, it is clear.
Okay. Now we'll talk about motion of vehicles. Okay, let's think about the vehicles. So stopping vehicles as quickly as possible is an emergency is important, but many factors affect this. The driver's reaction and the road and the vehicle condition play a part, as well as mass and speed. So when you are braking a car and you are trying to stop, so how many things is impacting? Driver's reaction. Driver's reaction how?
Driver's reaction time, the stopping distance, and the braking point.
Yeah. So driver's reaction, the road, the how road is, it is more slippery or less slippery. That means friction. It is impacting how far it will go. Okay. Vehicle condition. If it is a new vehicle, it will work properly. If it is old, it may not work properly, right? So these are the conditions play a important part while vehicle you want to stop. So what is stopping distance then? In an emergency,
stopping distance is the stopping distance is the car is where this is the distance traveled after the brake has been pressed.
Okay. So in an emergency, a driver must bring their vehicles to a stop in the shortest distance possible. Okay. So actually stopping distance is not the braking distance. The formula is like this: stopping distance is equal to thinking distance. Distance plus braking distance. Braking distance. So what is thinking distance? Thinking distance is the distance a vehicle travels in the time it takes for the driver to apply the brakes after realizing they need to stop. Okay. That means when you are driving a car, okay, in certain condition, you will press the brake, right? But in between this, you will keep on thinking, should I brake? Is it right time to brake? Okay, it will take some time, right? The driver is thinking,
Yes.
press the brake of the car. Okay, this is called thinking time. The person driving the car, his brain is working for certain time to press the brake to stop the car. So this is also a duration. Suppose you are driving a car, you saw that one cow is going crossing the road, so you are thinking that you should stop the brake, right? It may take 1 or 2 seconds or 3 seconds, 4 seconds, but there is time to think. It's not like that you have in mind you are thinking that I must stop this and car will stop. No, you are thinking as well as you need to press the brake. If you don't press the brake, then even though you are thinking, car will not stop, right? So the thinking distance, distance a vehicle travels in a time it takes for the driver to apply the brake after realizing they need to stop. What is braking time? Braking distance? Braking distance is the distance a vehicle travels in the time after the driver has applied the brake. Got this point? As soon as your leg press the brake of a car, after pressing the brake, how long it crosses? That is the braking distance. Is it clear? Another one is reaction time. What is reaction time? Reaction time
is the time taken for the driver to react to the happening.
Exactly. So reaction time vary from person to person, but typically it is 0.2 second to 0.9 second. Usually person reaction takes this much of time. Okay. But it may vary. Why it may vary? The driver's reaction time can be affected by what? Tiredness. If you are tired, you cannot think properly, right? Then drug. If driver has taken the drug, his brain will not work. If driver took the alcohol, okay, then his brain may not work properly. Distraction. He might be distracted. That means his mind is not proper. Somehow he is having sorrow. So this distraction might happen. And this will impact what? Reaction time. That means reaction time will impact tiredness, then drug, then alcohol, then distraction. Okay. So longer reaction time increase the thinking distance when stopping for a given speed. Okay. If reaction time is longer, that means thinking time will increase, right? Because his brain is not working in that moment in this duration. Okay. So he's thinking slowly or he's not able to take that decision that will impact the thinking distance.
Like
a car, let's say one car is here. So driver is thinking that he need to stop. One cow is crossing the road. He is thinking. So during this position, till he take the decision to press the brake, he might cross this amount of distance. Okay. Got this point? Suppose you are riding a car, you are driving a car, you are thinking, yes, I must stop. But during the thinking and pressing the brake, the car will be moving some distance, right? It's in the moving position, carrying the speed, right? So this is thinking distance. So as soon this guy press the brake, it might go till this position. Okay. This is after pressing the brake, the point that it reached. This is the braking distance. Okay. What is one?
Okay. Yes.
So there are different ways to measure the reaction time. One simple method involves dropping a ruler between someone's open thumb and 4 fingers. Higher the reaction time needed to grasp the falling ruler, further the ruler falls before being stopped. The ruler can be adjusted to measure in second rather than in millisecond. That means a ruler is, suppose if I throw a ruler in front of you, you will take some decision, right? I must catch this ruler. So the point, at point of time, your hand is moving and you catch this. This will be the thinking distance that you are thinking I must hold it or not. Okay. Then we are having braking distance. What is braking distance? Braking distance of vehicles can be increased by what? The distance can be increased by some point.
By the reaction time.
Reaction time is over. Now brake has been pressed. Now the how much distance it will go, it depends on certain condition. That is, one condition is poor road and weather condition, such as gravel or wet or icy road, less friction between tires and the road. So if less friction is there, that means box will go longer. That means the car will go longer, right?
Yes.
So this is the road condition is impacting. The another one is poor vehicle condition, such as on brakes or on tires, less friction between brakes and wheels. Suppose your brake is not working properly, okay, or your tire, this you have seen the tire, right? In the tire you will see like this cross, okay, that because of to make the friction with the road. If this goes eliminated due to the friction or somehow it has broken, then it will go longer time, longer distance, because brake will not work.
Yes.
The friction is less. So more mass in the vehicles, that means extra passenger, for example, the braking friction has to work for a greater distance to remove the larger kinetic energy. So if vehicle is having the mass, that means its mass is higher, then it will go longer. Because why? We know F is equal to ma, right? M is what? Mass. Okay. So
mass and
acceleration.
Acceleration.
Yeah. If m is less, like this, if we have this 2m, 2 kg, that means it will be 2a. A is constant, acceleration is constant. If mass is 40, that means it will be 40a. That means force will be higher, right? The force is getting higher. So the more force means it will go longer places, longer distance. So less mass, the weight of the vehicles, mass, that means it will go lesser. So when a force is applied to the brake of a vehicle, there is work done by friction between the brake and the wheel. This reduces the kinetic energy of the vehicles, slowing it down and causing the temperature of the brake to increase. So the temperature of the brake will increase, because the more friction is there, it will create what? It will create heat energy, right? Suppose yes. if you rub your hand, you will see that your hand is getting hotter. Okay. So greater braking force produce a greater deceleration. Large deceleration may cause the brake to overheat, and driver may also lose control of the vehicles. If hard brake is given, that means suddenly it will be deaccelerated, so it will be overheated, and sometimes the driver may lose the control. Got this point?
Yes.
So your thinking distance and the brake distance is clear?
Yes.
So now calculating stopping distance. How will calculate the stopping distance? It is important to be able to estimate how the stopping distance for vehicles varies with different speed. Calculate the work done is bringing a moving vehicle to a rest. So let's see a diagram. See the diagram. What is diagram is showing? It is important to note the thinking distance. The red color is thinking distance. This color is braking distance. So speed, if speed is higher, that means if A is higher, that also it will be going faster, longer time, right? Let's say both are same mass, two mass. One is speed in the speed 100, one is in the speed of 10. That means the force will be what? 200 Newton, here 20 Newton. So mass, if mass is greater or if acceleration of speed is greater, the distance will be covered more. See here, okay? This is distance. Got this point? So it is important to note that the thinking distance is proportional to the starting speed. This is because the reaction time is taken as a constant and distance equals to speed into time. So distance is what? Speed into time. So braking force, what is braking force? However, the braking distance increase 4 times each time the starting speed double. If it is doubling, then it will be increasing. The distance will be increasing. This is because the work done is bringing a car to a rest, means removing all of its kinetic energy. So when we are trying to stop a car, the more kinetic energy will be there, and that need to be neutralized to make it force. So work done equals to what we know. Work done equals to kinetic energy. Okay. So what is kinetic energy? Kinetic energy is
the
braking force into distance. That how distance it has. This distance. Okay. That means if we present this one as W, it will be braking force if we give F and distance is D. So this is the equation. Okay. But what we know, kinetic energy. With the kinetic energy, we know what? Half mass, then velocity square, V square. This is the formula we know, kinetic energy. Isn't it? We have done this one before. Shanad?
This is
kinetic energy.
Is
yeah, tell me.
Kinetic energy is equals to half meter. What is this?
Velocity square. Okay.
Velocity square.
Half mass, velocity square. This is kinetic energy. This means kinetic energy is what? Work done is kinetic energy, right? And this is braking force and into distance. So we can write this kind of braking force and distance. So we can write F into D. So this will be half mv square. You can write like this, right?
Yes.
So for the fixed maximum braking force, the braking distance is proportional to the square of the velocity. Do fixed maximum braking force. Okay, fixed braking maximum braking force is fixed, constant. So what we can see, so braking distance, this braking distance is proportional to the square of velocity. If we check this one, force is this, that means D equals to what? D is proportional to velocity square. Okay. So for the car, mass is same for the same car, right? So force of is same. So the variation will be done on D and velocity square. So we can write, see, if you want to see this one, we can write D equals to half m by, this will go down, F V square. So this is the constant always. Why constant? Because the car mass is always same. Okay. Force also we are keeping the constant. So the distance will be depend on the velocity square, how speed it's going. Okay, same car in different speed, it will cover different braking distance, isn't it?
Yes.
Okay. So this is how we can see thinking distance calculation. How we can calculate the thinking distance. A car travel at, let's say car travel at 12 meter per second. Okay. The driver has reaction time of 0.5 second and sees a cat run into the road ahead. What is thinking distance as the driver react? So that is what distance equals to speed into time.
Speed into time.
Time. That means velocity into time, right? So here,
yes,
distance velocity is what? Velocity given 12 meter per second. Then we'll write 12 meter per second into time is what? His reaction time was
0.5 second.
0.5 second. That means thinking distance is what? Thinking distance is equal to
thinking distance is
6 meter. Okay. See, this is second in downward. This second will be cancelled. So this will be a meter. Okay. Now let's see how we can calculate the braking distance. How we can calculate the braking distance? Let's take an example.
Braking distance can be calculated by dividing
the formula that we have already derived, right? See. So this is a question, okay? The car in the previous example has total mass of 900 kg with a braking force of 2000 Newton. What will be the braking distance? Okay. So previously what formula we have derived? We have derived F into D equals
to half meter velocity square.
Velocity square. Okay. So what given here?
Yes.
Braking.
Mass and force is given.
Mass and force is given. This is what? F. Okay. This is mass.
M.
M. Okay.
M.
Okay. So we'll need to find what? We'll need to find the distance.
Find the distance.
What will be the V? V is say the car in the previous example. That means V is 12 meter per second. V equals to 12 meter per second because it's referring to previous example. Okay. That means 12 meter was V. Okay. So let's put all the values. We can segregate the D half M V square by F. We can write like this. We can take the cross here, right? So now put half. M is what? 900 kg. V
900 kg divided by 2 is 450.
Divided by 200 Newton. Okay. So if we cross this one, okay, then what we'll get? 9 is there, 20 is there. We can write in this.
We'll get a decimal.
9 into 12 meter per second into 12 meter per second, right? Since it's square. So we'll get 20 here. So with 2 we can write it's a 6. It's a 6. With this 2 we can write, or we can cross by 4. It will be 5, and this will be 3. Okay.
Okay.
This is half 900. So if you calculate with this calculator, then what will happen? 9. Okay, let's see. 900 into 12 into 12, okay, divided by 2000. It's a 2000, yes. Then again divided by 2. It's becoming 34.4. 2.4, right, meter. This is the result. So we found this what? This is braking distance.
Braking distance.
Braking distance. So what if so now what is the stopping distance? Stopping distance of the car?
Stopping distance is, the formula for stopping distance was distance divided by velocity.
No, stopping distance is nothing but summation of thinking distance.
So thinking distance divided
by braking distance.
Plus braking distance.
Okay. So what we have thinking distance? We have thinking distance 6 meters.
Is 6 meters and the braking distance is 32.4 meters.
Plus braking distance is 32.4 meters. That means it will be
38.4 meters.
Okay. This is the result. Got this one?
Yeah. Yes.
To solve this kind of problem, we just need to understand the formula. Two formula: thinking distance and braking distance, and stopping distance is the sum of thinking distance plus braking distance. So the formula for thinking distance is velocity into time. Okay, thinking time into velocity. For this distance, there's a braking force, F into D equals to half mv square. That means you can find the braking distance from here. Okay, so then when we found all the braking distance and thinking distance, we can add both. We'll get the stopping distance. Clear?
Clear.
Okay, all right. So shall we go for an exam?
Okay.
Let's go for test. Can you see this?
Yes.
To stop a vehicle quickly, what is the thinking distance?
What is the thinking distance? The thinking distance is the distance. Wait. Is the distance traveled during the driver's reaction time.
Okay. What is the formula for calculating the stopping distance for a vehicle?
Stopping distance is equals to thinking distance plus braking distance.
This one, right?
Yes.
Which of these would not increase braking distance?
Which would not increase braking distance?
Yes. Which of would not increase braking distance? Remember, try to understand the question first.
Increase braking distance. The drinking alcohol.
Okay. Because drinking alcohol is a impact of
increases
thinking
reaction time.
Yes. But driving faster, it will increase because A will be greater. Road being
Yes.
icy, the friction. Okay.
Less.
This is a good estimate of human reaction time.
0.5.
0.5. Okay. Why would taking a more passengers increase a car's stopping distance?
Greater the mass means there is more kinetic energy for the brakes to transfer.
Greater mass means there is more kinetic energy for the brake to transfer. Okay. Which of these will be increased by making a car travel faster?
Which of these will be increased by making a car travel faster?
Car travel faster. Thinking distance, braking distance. Thinking distance only, braking distance only.
Making a car travel faster. The braking distance.
Which of these will be increased by making it travel faster? Braking distance only. Okay. Why? Because F is equal to ma, right? The more acceleration,
Yes.
the force will be more. What would be the effect of replacing old tires for new one?
Increased braking distance.
Would be effect of replacing old tire for new one.
Or reduced braking distance.
Reduced braking distance. Why?
Because the better tires will have like more friction.
Okay. So which of these is a hazard of large vehicle deceleration?
Brakes may overheat.
Brake may overheat. The vehicle stop in a very short distance. Vehicle is easily controlled. Brakes may overheat. How is the braking force connected to the distance needed to stop a vehicle from 20 meters per second?
Connected to the distance needed to stop a vehicle from 20 meters per second.
That means 20 meters per second is the velocity.
Velocity. The braking force connected to the distance needed to stop a vehicle from 20 meters per second. The large braking force reduces the braking distance.
Large braking force reduces the braking distance. Okay. If a car's braking distance at 10 meters per second is 26 meters, what will be the braking distance be at 20 meters per second?
If a car's braking distance 20 meters per second is 26 meters, what will the braking distance be at 20 meters square? 20 per second. The velocity is 10 meters per second. The distance is 26 meters.
You may need to calculate.
But what is the force?
What will be the braking distance be at 20 meters per second?
Wait. If 1 meter per second is...
Use the formula.
Then at 20 meters per second, the distance will be 52.
52 is not there.
Oh.
Let's check. What we know? We know
Force times distance is equals to mass times velocity. Half mass times velocity square.
Okay. So here, what we have? We have distance. That means value of d. That is what?
26 meters.
Then we have velocity, half m v square means 10 square. Okay,
10 meters.
10 meters.
10 meters.
We don't have f. Okay, the car braking.
F or the mass.
Yes. So here, F force will depend what? Based on the velocity, because the mass is same, right?
Yes.
So now what will be the braking distance be 20 meters per second. So here F into another equation, we get D is not given, then half m is given, then it's given 20 meter per second square. Okay, this is one for first one, this is for second one, where the mass is not given. So from here, what we can see the mass is same. Force will be depend on this velocity square. What we learned before, distance is proportional to velocity square, right?
Yes.
So distance, if proportional to velocity square, means if velocity increase, distance will be increased. Okay. So since the velocity is double, then what will be the?
And then it will be double 26 meter times 2.
Time 2.
26 meter times 2. Yes.
Is that so?
Yes.
So what will be the velocity?
Velocity is 20 meters per second.
Guess one. We'll able to understand.
But isn't the answer going to be 52?
See, very easily you can think this one. So it was before 10. Okay, what percentage it has increased? From 10,
100%.
20. 1 means 20 by 10. 100 means 20 into 100 divided by 10, right? So 200% it has increased. Okay, so the distance will be proportionally increased 200%. Okay, so what was the distance?
10 meter.
26. So what is the percent of 26? 200%. 200% of 26. What will be? 2 into
200% times 26 is 5200.
5200. How come?
Multiply them.
200%. Just check this 200%.
Or 200%.
And 26 into
it's 52. The answer is 52.
But 52 is not there.
It must be wrong. Then how? What is the answer then?
Okay, let's think about the 46. Okay, it will actually
Yes.
check score. How much you? 8. You got 8 out of 10. First one is okay. Which one is incorrect? This one. Which of these will be increased by making a car travel faster? Braking distance only. The thinking distance and braking distance are both larger at the greater speed.
Oh, yes.
Was there anything like this? The wrong one is last one. Okay. At double speed, the kinetic energy is 4 times bigger. So the braking speed, sorry, it was proportional to this square, right? So it will be 4 times bigger. 4 into bigger at 104. It was my mistake. I said this V is D proportional to V square, but we have considered the not square.
Square.
We didn't consider the square. That's why then it has.
Oh.
So you understood this one?
Yes.
Proportional means it will be proportional to square. Okay.
Yep.
Okay. I hope it's working fine. Anything else you want to know?
No.
Okay.
No.
Bye then.
Bye.